Hi, welcome to part 5 of the video series about vertical projectile motion. In the previous video, we solved 2 examples to understand how to use equations in this topic. In this video, we are going to solve another couple of examples. An object is thrown straight upward with an initial velocity of 40 meters per second. How long does it take to reach its maximum height above its launch point? Assume no air resistance and g gravitational acceleration is 9.8 meters per second square. As it was mentioned before, the first step in this topic is deciding the positive direction. A ball was thrown upwards, therefore we choose that direction as a positive one. Next, we summarize the information given in the question. Initial velocity of the ball is 40 meters per second. Acceleration is downwards, therefore its value is negative 9.8 meters per second square. Even though it is not specified directly, we can recall from the notes that at the maximum height, the velocity of an object is equal to 0. We must calculate the time it takes the ball to reach this point. An equation which involves all these quantities is V final is equal to V initial plus A times delta t. Final velocity is 0. Initial velocity is 40. Gravitational acceleration is negative 9.8 meters per second square. We can move 9.8 times delta t to the left side of the equation. Delta t can be calculated by taking the ratio of 40 and 9.8, which is equal to 4,08 meters. The second example is similar to the first one. The only difference is that now, instead of calculating the time the ball reached the maximum height, we need to calculate the time it takes for the ball to reach the initial point. We are going to use 2 different methods to solve this question. Before proceeding with the solution, let's draw the diagram and then summarize all the information we know. The ball is thrown up with an initial velocity of 40 meters per second. It rises till maximum height and then falls back. As points A and B are on the same level, velocities at these points are equal but in opposite directions. Therefore, the final velocity of the ball at point B is negative 40 meters per second. Gravitational acceleration is negative 9.8 as we consider upwards as a positive direction and it is acting downwards. We are asked to calculate the time it reached the ground again. We can use the formula V final is equal to V initial plus A times delta t to solve this question. Final velocity is negative 40, initial velocity is positive 40, gravitational acceleration is negative 9.8. Minus 40 on the left side of the equation becomes plus 40 on the right side. Similarly, minus 9.8 times delta t on the right side becomes positive 9.8 times delta t on the left. 40 plus 40 is equal to 80. Delta t is equal to 80 over 9.8, which is equal to 8.16 seconds. The second method is useful if time to reach the maximum height is already known. As points A and B are at the same level, time intervals between these points and the maximum height are equal. In example 3, we have calculated that the time to reach the maximum height is 4.08 seconds. So is the time to fall back to the ground. Therefore, the total time is 2 times 4.08, which is equal to 8.16 seconds. In this video, we solved another 2 examples. More examples will follow in the next few videos. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.